All right. So, just by way of introduction to you all, everybody here is a former coworker of mine. Ramir wins for being the oldest coworker. I think we worked together 15 years ago. Um, so, what I'm going to be doing tonight is just going over a basic lab on getting working with Chef and Kitchen CI. So I'm going to talk a little bit before we get started on about Chef, but I'm going to try to get right into doing the lab as fast as possible. So um, most of you already have a pretty good idea of what Chef does. And that's why you're here in the first place. So I'm going to talk a little bit about some of the ideas behind Chef, as far as how they how it builds a manifest and the item potency aspects of Chef. So essentially, people understand this idea of config management. That they're managing the configuration on a machine, but in fact, actually, what Chef is doing is that it is you're building a manifest for that machine and in a declarative language that you can run over and over and over again to make sure that that machine stays in the state that you want it to be in. So what initially happens on a Chef run is that a Chef client will connect to a Chef server and pull down a manifest of the way that machine should look, and then using a system called OHI, it'll build up a number of facts about the system, and then build a node object and compare the way the system should look with the way the system does look, and then go through a convergence process to bring the machine into policy the way that you want it to work. So Chef's all written basically in Ruby. And the bits that we're going to be getting into, we're not going to be working with a Chef server, but we're going to be working with a system called Kitchen CI that allows you to do continuous integration testing with your Chef scripts, which will create a virtual on your machine and then run through a Chef configuration on that machine, and then we'll run through some integration tests at the end of that to make sure that the machine that the Chef scripts are working the way that we want them to. So the thing we're going to actually be creating is called a wrapper cookbook. This is actually the kind of the most common cookbook that you end up creating. That most of the time, everything that you could possibly want to do on a machine has already been done by the community, and you just want to take those nuggets of an idea and then extend on them. And so, for that, we create these wrapper cookbooks where we use an existing community cookbook and then change that cookbook to be to fit what we actually wanted. And specifically in the case we're using tonight, that we're going to be using a cookbook that has some things that are broken with it, and we're going to fix them. But we're going to fix them in our wrapper cookbook. If you want to be like a good citizen, maybe what you'd normally do is actually submit a pull request back to the maintainer of the cookbook to fix the things that you find are broken. But and generally that would be a good idea, but most of the time you'd have to wait for them to actually put the pull request in, and you can fix these things often in your own wrapper cookbooks right away. So I'm assuming that everybody got the pre-work stuff that I sent out run through. If you didn't, don't worry, we're recording this, and you can watch the parts that I go through back later, and also we can hook up later and we can figure out why you weren't able to, what parts of it you had trouble with. Somebody did point out to me that I neglected to put that you need to download and install Vagrant, which, my bad. I just didn't remember that part of it. So like I said, if you got stuck on any of the pre-download work that I gave out, we can hook up later and go over it and figure out what parts are broken. So let's start here. Let's share the screen. Ooh, that's fun. So to get started, we're gonna start off with a terminal. And I'm just going into a random directory that I tend to put code in, and you can choose your own there. And we're going to start off with the chef command and do a chef generate app, and I'm going to call this test chef. This basically doesn't do too terribly much, but you want to get used to using the chef command to generate the templates to get your stuff going. So you can see in here it created a cookbooks directory and a README and some hidden files. So we're now going to go one step in from there and go to cookbooks. Let me make the font a little bigger here so you guys see that. Can everybody read that okay? Anyone?
Yeah.
Okay, cool. So in here there's already a single cookbook. I'm going to say chef generate, and we're going to generate a cookbook this time. And the wrapper cookbook that we're going to be creating is for Minecraft. So we're going to create a Minecraft server tonight. So if we go into the my Minecraft directory, so that this far we can see I'm down in test chef cookbooks, my Minecraft, and it's created a number of files for us to get started. We're going to switch over to a browser real briefly here, so we can talk about the Chef Supermarket. So the way that chef people share their recipes and cookbooks is using the Chef Supermarket. It basically anything you were looking for a daemon to set up or a package to install, this is the first place you should start. Here we're gonna look for a Minecraft cookbook, and we first one here gives us. We can go over and look at the source for this cookbook. We will eventually want to go do that. But just to use this cookbook, we're going to need to copy this line of text right here, and you can see it's giving us instructions for bookshelf, librarian, and knife. We're going to be using bookshelf, to manage our cookbooks. So now I'm going to go over to Sublime Text here, and I am going to open the directory that we were just in. It's this guy. And I called that Test Chef, cookbooks, and we're just going to be working out of that directory all night. So there. And you can see that I already got a Burks file. That was one of the things that the Chef Generate did for me. I'm going to open up that file, and then right here I'm going to paste in that line that we got from the Chef Supermarket, right? All right. Let's make it a little bigger so people can see. We need to add this in a couple more places, but I'm just writing out that file. Over here, our cookbook is now going to depend on this this other cookbook. So I'm to the metadata file. I'm adding a depends Minecraft. Okay. In this section up here, you can see it's put in you know, some information about us that we could fix up. I'm not going to care too terribly much about this right now, but normally you would supply your email address, your name, and as you're using that Chef Generate command, you can actually give it some command line arguments that will populate the stuff, as well as that allows you to use your own templating, where you can extend it and add a lot of extra templating, put in your own custom licenses and stuff. The README file here also just gives us an empty README to get going. So that's our first two steps here. We have added the Minecraft cookbook to the Burks file and to the metadata file. And our next step would normally be to hop in here and now include the Minecraft cookbook in our recipe. But we're going to quickly, because we want to do this in a TDD way, start with our chef spec testing. So I'm back at the console here, and I'm going to make directory spec, and then I'm going to make directory spec recipes. Okay, and I'm going to head back over to our Sublime text. And in spec here, I'm going to need to create a new file. This is going to be our spec helper. So what we're going to be using to initially do our unit testing with is chef spec, which is a version of well, it's basically our spec with chef specific things in it. So I have a gist here of what our spec helper should look like. I'm going to paste that into the chat so you guys can all pick that up. All right, we'll get rid of the infinite windows there. Um, so I'm just going to copy this info here. I'll go over this real briefly, what it's doing, but essentially it is just requiring helper.rb. It's requiring chef spec and Burke shelf, and then it's setting a couple of configuration parameters. Okay, and now under recipes, we're going to create a new file, and this is going to be our actual spec test. So default spec RB, and this uses, if you're at all familiar with RSpec syntax, this uses basic RSpec syntax. I have a second gist that I'm going to send out here in just a second, but I want to go over first what we're going to do. So in the beginning of our test here, we're requiring our spec helper, and then we are describing our cookbook, and then we are setting up a chef solo run, and we're going to then converge this recipe. So at this point, we can actually just run a test and watch it fail. So our spec color. Our spec is just going to run through anything in the spec folder and run those tests. And actually, because we have no examples at this point, then it does not fail. So let's go ahead and add an example of something it should do. So we're going to say it should include recipe Minecraft. And now we have a failure because we have not added that piece of code yet. So the include recipe line here, we're going to go over and add that into our actual recipe. Include recipe Minecraft. It's actually, when I say include recipe Minecraft, this means to include the default recipe from the Minecraft cookbook. It just assumes default if I don't actually specify a recipe. Minecraft cookbook could have a number of different recipes in it, and whichever one I actually wanted to run, I would have to put its name here, but again, just specifying the cookbook name means to include the default recipe. So, color again, let's see. And we have another failure, but this time the failure is not because we were missing a line of code, but because the Minecraft cookbook actually runs a command. And that this command needs to be stubbed so that RSpec, because RSpec couldn't safely run this command, we have to stub the command out and have basically RSpec fake the results of this command. So we're going to go back to our spec file here. And then we're going to put in a little before block and say stub command false. So the actual command that Chef's going to be running at the command line is this command, which is listing all RPMs on the system and then grepping for the run it RPM, and we're going to tell it to return false for this this command. All right, so now our spec is succeeding. We have a really basic recipe that is just going to include the Minecraft cookbook. So the type of testing that we have done up to this point is a unit test. And what we would like to do now is move on to an actual integration test. So I'm going to make another directory and call it test. And in that, I'm going to make a directory called integration. And then in there, I'm going to make another directory called default. And then inside that, I'm going to make another directory called server spec. Okay, so our spec and Chef spec is really great for doing unit testing, but not so awesome for doing integration testing. And so to do our integration testing, we're going to be using server spec. You can find out about server spec here at serverspec.org. Kitchen CI specifically, it supports several different testing frameworks, and this is one of them. And when we actually go to execute these tests, we're going to be using the Kitchen CI to execute this set of tests. So let me send you guys really quickly the gist for the RSpec stuff that is there. And we're also going to need a spec helper for server spec, and so I will send you the gist that we have for that, and we'll get started creating that. All right, so we've created integration or test, integration, default, and server spec. And in server spec, I'm going to create a new file and paste in, not the gist, stuff here for our spec helper. Again, this right now is very simple. It doesn't have much in it, but you can put in a fair amount of server spec configuration into your spec helper here. I'm now going to create another file. Call this one default underscore. No, we're gonna, sorry, not default. We're going to call this one service underscore spec.rv, and then we're going to say require spec helper, and then you'll see that the language to this is similar to what we were using in Chef Spec, because this is also based around our spec language. So say describe service, Minecraft, to it should be running. It's a very simple integration test. It it is only going to check that our service is running. And if you notice here, it doesn't care about which distro that we're using, and we're actually going to be testing with 2 different distros. We're going to be testing with Ubuntu and CentOS. And we're going to use that same server spec test to test both distros, because server spec understands, services in general. So we don't have to do anything special for each different distro. So we're going back to the command line here, and now we're going to type kitchen list, and this gives you a list of the 2 different profiles that we've got set up here to do our testing with. You see, this was all created by the chef generate cookbook command. So back here we can say chef, or sorry, kitchen create, and it will now, using Vagrant, create 2 different virtual boxes. And actually, I'm going to cancel it here because this is do 1 at a time. That will do 2 at a time. It's going to create 2 new virtual boxes for us to with Vagrant for us to run our chef scripts against and test to make sure that they work. So, does anybody have any questions at this point? While we're waiting.
Yeah, so I asked one in the chat. I don't know if you got to it, but basically, why is the everything under test directory not the spec directory? Does it not matter, or is it just sort of like you sort of name it whatever?
No. There are conventions that
okay, cool.
that have just kind of taken off in the chef's world, and inherently everything I tell you tonight, that I don't know, a good 60% of this stuff is not going to last 6 months, because things in Chef are changing really rapidly. We're going through what to me seems like the best practices right at this moment. I've been using Chef for about a year now, and the best practices for Chef have changed really radically in the last year. The directory structure I've set up here is just kind of what everybody else is doing right at the moment, or at least most of the people that I, check out. So for kitchen, it definitely does assume that your tests and everything is going to be, all the pieces it needs are going to be under a directory called test and integration. And what you're doing is you're setting up in your kitchen file, we set up different suites of tests. And so everything we've set up here is for the default suite. I can create multiple different suites and then run those tests against multiple different operating systems at the same time. And Kitchen expects everything to be in this particular directory structure. So here we've created the two machines. I can, if I say kitchen list again, I can see that I've got two machines up. I'm now going to say kitchen converge, and that will, this is going to take just a little bit. What it's actually doing is it's going to, I did again, let's do this in parallel. It's going to install the Chef client using an omnibus installer on each one of these, on both of these machines that we've set up. And then it's going to upload all the recipes that we put up there. And then actually, in here, because our kitchen file says its provisioner is Chef 0, it's using a Chef 0 server on each one of these machines. So maybe I should take just a second and explain the difference between Chef 0, Chef Solo, and Chef Server, and the ops code hosted Chef Server. So you can either run a Chef Server yourself. Ops code offers as a service that you can have them host a Chef server for you. You can upload your Chef recipes there and have your clients connect to it to get their Chef manifest stuff. There's these two other things that exist, which is a Chef solo run, which allows recipes to be just applied directly to a machine without a server at all, or Chef 0, in which case it will kind of fake a server. It'll bring up a server all in memory, and you can populate all the things that you would normally have in a Chef server in that server, but it goes away at the end of your run. So this is important because you can use there's things that we're not going to cover here tonight in the lab that are probably the most powerful pieces of Chef that involve using a Chef server, and that is that you can put information on a Chef server and use that as part of configuration on other machines. And you can do that in a number of different ways. One is that every time a Chef client runs on a machine, it collects a lot of information about that machine and then uploads that to the Chef server, which then other Chef servers or other Chef clients in their configuration can search through that information and use that config in their own config. An example of this would be if you were setting up an Elasticsearch cluster and you wanted to put the addresses of all the other Elasticsearch nodes in your Elasticsearch YAML, you can have the Chef client, when it runs, search the Chef server for all other machines that have an Elasticsearch role attached to them, and then populate their addresses in your configuration. Other things you can do are you can rely on you can have data bags where you're independent of your actual Chef recipes and cookbooks, that you would have data that you would populate on the Chef server and then allow recipes to be able to pull down that information. Reasons that you might want to do this, and kind of the most common are doing encrypted data bags where you have information like SSL keys or private SSH keys that you need to be able to put on your machines, but you don't want to put in your into your cookbooks. You can create data bags, and actually often the public cookbooks that you'll use off of the supermarket will require data bags to run, where you create basically some data that cookbook will run and pull the information down to finish converging. So in this case, what we're doing though, Kitchen CI is meant for doing integration testing of your chef recipes. The upshot is you do end up with a virtual that is sitting on your machine that ran through a chef recipe. Some people ask me like, oh, could you use this for a development environment? And you probably could. It's definitely not designed with that in mind. It's designed for testing out your recipes. But if you wanted to, you could probably create a recipe and send that, or a cookbook, and then send that over to somebody, and all they would have to do once they had the list of things that we've gotten installed here tonight is, type kitchen create and kitchen converge, and then they would have a virtual on their machine that was built according to some recipes that you have created. There's probably better ways to do that. At my work right now, we're using just straight Vagrant, and we're starting to use Docker a lot to create those kinds of environments. And at the end of this, I'll get into some stuff that's kind of on the just coming out for Chef, and which might be a better solution for that particular type of problem, like creating development environments for people. Chef's got some stuff that's just now coming out that would make that easy to do. Now, this is taking a little longer than I wanted to, but does anybody else have any other questions while we're waiting? Let's see here. Well, I guess I can talk a little bit about this is out of order, but since we were already talking about the development environment type stuff, all of what I'm going over tonight just is config management stuff, and Chef now has it has other tools. That are not just configuration management. There's a tool that comes with Chef called Knife, which is this kind of all-purpose, Swiss Army knife kind of tool that ends up doing quite a lot of things. But with Knife, you can do things like create virtuals in different cloud systems. I use it for creation of all our AWS instances. So basically it's an orchestration tool. But the new piece that's coming out from Chef is something called Chef Provisioning. And in provisioning, beyond just being able to create recipes for machines and how you would like them to look, you're able to actually define architecture. So you could say not just that like I want a machine that would run Apache to look like this, but you could say I want 6 machines running my Apache recipe. And I want them to be of this flavor instance in Amazon, or I want those to be Docker instances. So this is new stuff that is not quite ready just yet, but looks like it's going to be kind of prime time in the next couple of months here. So we've moved on here. As you can see on my screen, it installed the client, and it has started to sync up all of the cookbooks. and then it's now actually running through the cookbooks on both machines. Now, to run a Minecraft server, there are quite a lot of pieces. It's going to need Java, and let's quickly pop over to that Minecraft recipe here, or cookbook, and take a look at this guy. So this particular cookbook relies on a couple of other community cookbooks, the Java cookbook and the Run It cookbook. If you guys aren't familiar with Run It is an RC system that in this particular recipe is going to replace the normal RC system on the system or not replace, but add this extra RC system to keep the Minecraft server running. So it explains briefly here what the default recipe does, and then it has several other recipes in it, and then it gives us some attributes that we could go in and change to customize this recipe. And as we're going to run into here in a minute, we are going to need to change some of those attributes. So to take a look at that, up here in our recipe, we don't yet have a attributes directory, so I'm going to add that. And then I'm going to create a new file called default. Okay, so Chef will create a node object, and in that node object is going to have a number of attributes. And some of those attributes are going to come from our recipe, and some of those attributes will come from a system called OHI, which just basically gathers facts about the machine that we're running on. And we can create conditionals to run things based on those attributes. In this case, this recipe that we're using has created some conditionals, and that we can change these attributes to cause different things to happen in the code. Let's take a look at our. Looks like we have installed Java on one of the two machines, and it's now starting to install on the second machine. So the way that we would get at these attributes, he's given us a list of. By the way, this Greg here is no connection to me. That's just another Greg. He's given us a list of attributes that we can change out. So one of these in here is like a message of the day. Default. All right, so I'll check some. There's no. Well, we could change the user and group. That's a simple one. So in our own wrapper cookbook here, if I come in here and set, now he's set as default his user to be MC server. We can go ahead and set ours to be just Minecraft. Default group. Minecraft. Okay, now we sliding back over to here, we have failed to install the OpenJDK on the Ubuntu machine. So the CentOS machine looks like it worked, but or no, I guess actually it had a failure too. So the problem that he's got here is that he is trying to install OpenJDK without running basically an apt-get update. You know, so the cached, and we could fix this easily just by logging on to that virtual. And by the way, the way to do this, kitchen, is the kitchen list, log in, and we'd say default Ubuntu to log into the virtual that's on our machine. You can fix this easily by typing, you know, apt-get update, and when we're working out the problem, that may be what we do. We come in here and you know, try some commands to figure out what to do to fix this. But once we know what those commands are, then we can put those commands into Chef and then destroy this instance and start it back up again. And make sure that our chef is able to create this instance from scratch and have it work every time. Now, in this particular case, the easiest way to fix this problem is just to include the apt recipe from Chef, or cookbook from Chef. So we're going to go back to the supermarket. Apt. It's the version of the cookbook we want. And if we take a look here, these guys tell us that if we set a particular attribute, the apt compile time attribute, it will make sure to force the cacher client right at the very beginning. So to add this cookbook, I'm going to our Burks file, adding the cookbook there, and then putting in a depends in our metadata file. And then over on our recipe, well, wait, let's be good TDD people and add in a spec for that first. So it should include recipe apt. I should test it to make sure it fails, but we're running tight on time here. Okay, and now we're going to add that attribute that we saw before, which again, if we come back here, it says you know, apt compile time update. default apt. Anyway. Is true. Okay, if we run through our spec test again. And it succeeded there. And now we're going to do kitchen converge again. Actually, I'm going to converge just specifically the Ubuntu recipe because that's the only one we fixed. So you can name which of the machines that you want to converge for, or create or list. So we can see that in the details here, it is now adding our apt cookbook and picking up all those updates that it would need before it could properly install Java. One of the things that Chef does to be idempotent is it runs a test before it does each thing to see whether it needs to do that thing again. It's basically, and there are a few cases in which this is on you while you're writing Chef code. So if you're using most of the DSL that's part of the Chef language, it's already this declarative idempotent language. But occasionally you have to tell it, like, don't do this thing if this file already exists or if this thing is already in this state. So if we browse through the actual recipe that we're running through, because all we've done is wrapped this recipe, at the beginning here, we're still in attributes. Let's go to recipes, default. So at the beginning here, they're including a Java recipe of some type, and it's using a node attribute. Now, as you can see in attributes, I'm using the word default. And I have several different words that I could use. You can say override. The node value here means that what the actual option finally gets compiled down to. The default attribute would be a series of you're basically setting defaults, and as each particular recipe gets applied, in the order that it gets applied, each one overwrites the previous defaults. And then if I want to make sure that no recipe past this point overwrites that using just another default, then I would use the word override, which then ensures that unless another override comes along, that value will stay the same. But then in our actual recipe, we use node because that's what the value finally converges down to. Here, they're including the run it recipe. We talked about this earlier, and then he's also including his own Minecraft user recipe, which we'll go back and take a look at. Well, let's take a look at that now. So this basically sets up a group and a user using the values that we saw in attributes. So that would have been that the previous default value was saying like MC server, and now we've changed that to be Minecraft. Let's go. Okay, the next bit here is it's setting a variable using a helper. We can get into explaining that in just a little bit. Then it's setting up a directory to install Minecraft into, and then setting recursively the permissions for that directory. You can see the different actions here. For every one of these providers that you have, there will be a default action. So if you don't specify the action, it'll just do whatever the default action is. I do believe that for directory, the default action is to create. In this case here, though, we're creating this with remote file. The default action is actually just to create, and we want to create only if this file does not exist. So it's using the create if missing action. Every provider has its own set of actions, and you can look these actions up either in the cookbook that you're getting the provider from or in chef code itself. Let's go back to see where we are with, yeah. Okay, now we're finally actually able to install Java, and that's what's going on over here. This is the Minecraft jar. And then we're going to follow the Minecraft service recipe. So if we go back up and take a look at this recipe, here he's created a case statement depending on which init style we set in our attributes, and yet he's only got one option here. So this is semi-pointless, but he probably meant it later to create different init styles. So he's specifically using a run it service to start Minecraft, and then passing another of options to the run it service. If we went and looked at the run it cookbook, we could read all about this provider and see what all these options mean. And then he's taking two different actions with this particular provider. So it is going to enable it and start it. Still installing Java. So next, we've got our install type. So you notice that what he's done here is that he's going to include a recipe of the name that is comes from whatever we set in attributes. So if we look at what the default is here under attributes, let's see. So let's see, saw that. Vanilla. So and then according to which what we've set this attribute to be, he sets a number of different attributes for where we're going to get Minecraft from, and the checksum for that that download, and then the server options that he's going to pass based on what install type we're going to do. So in our recipe, he's including this will end up saying, in our case, because we haven't changed this attribute, it'll end up saying, Minecraft vanilla. So if we take a look at the vanilla recipe, it does nothing. All right. So next, he's using a template here to create a file that will include the properties for running Minecraft. So templates in Chef are ERB templates. So if you're familiar with Ruby on Rails, then ERB templates will not be new to you. The directory structure for setting up templates is you create in the root of your cookbook a templates directory, and then create a default directory. This is because you can use other directories to have non-default templates. You can override one set of templates with another. So the template he was creating was our server's properties. So if we take a look at this, it's using basic ERB templating language to run through the set of attributes that we create for properties, and then create a config file out of those. So we take a look at those attributes. So I have to go back really quickly. Templates. Server properties. Use the Minecraft properties. Oh, he's put them in this so property attributes, and basically what this will end up doing is creating a config file with all of these different attributes. So earlier I was talking about we could override the message of the day, and that is where that particular attribute is. So let's take that guy and overwrite that attribute in our own recipe. Call it Chef Minecraft server. So let's see, we're still installing Java. Okay, to recipes, default. All right, so this is that's what our template is doing there. Here, he's also creating a number of other files. This is basic Ruby syntax. Creating an array of words and then looping through each one of those to create a file with the extension of text for each one of those. And then finally, and in these cases, this here was a template. This is just going to create a file with the content that is specified at this value here. So here there's not going to be a template of any kind. We're specifying the content of the file right in line with the provider. And the same goes for our last file here. And that covers what the basic default recipe is going to do. Do we have any questions at this point? Okay, so we've gotten past the portion where we need to install Java, and we have bombed out. The problem here is that the checksum does not match the actual file that we're trying to download. I've noticed this guy, I believe, does have a pull request that somebody has submitted to fix this problem, but we can fix it ourselves without, fixing his cookbook. So if we take a look at where he was downloading that file, we can generate the appropriate checksum and then overwrite the attribute where he set the checksum. So I'm going to download this file. And if we look up really quickly, let's go back to his recipe and see how he was downloading the file. So he's using the remote file provider and then providing this kind of checksum. Let's go look remote file up the syntax to find out what kind of checksum he's looking for. I believe it's a SHA-256. Yeah. So here they're looking for a SHA. So I've downloaded the file, and I'm just going to SHA sum 56. If you're following along on Linux, I believe the syntax for the SHA command is different here. I think you actually have a SHA sum 256 command. All right, there's our checksum. Copy copy that. And here, let's clean this up. So if we look quickly, the actual attribute that he's getting the checksum from here is Minecraft checksum. So if we overwrite default Minecraft checksum, we can go run converge again. And actually, this time we fixed it for both recipes, because that's what was causing the other one to fail as well. No, hold on. Oh, I've made a typo. So what Chef is actually doing in this case is it's downloading this file and placing it in it's actually the temp directory for the client. So in a regular Chef client, this generally ends up in a different spot because it's an environment variable. But it's going to put this file in a spot on the machine, and then run our checksum against it to make sure that it's good, and then we have to have some kind of installation step, which then moves that file into where we finally want it to go. See, it's now moved on. It's created our server properties and the other set of files that we wanted it to create. And it's started up the Minecraft service on at least one of the machines. It looks like that one. When I'm using the C parameter, that's telling it to run both of these machines in parallel. So we're actually getting the output of each of them at the same time. The green output is coming from the first machine, and the yellow output is coming from the second machine. And then you'll see some other colors here that relate to Chef explaining whether it had to do something to bring the machine into convergence. So because I'm running this, or it's getting to this part of the recipe for the first time, it had to create these files, and we're getting the output in white. As it runs additional times, that it should not have to actually create these files again unless they've changed for some reason. And you won't see this white output. And here, because I had to reload a service, you get the output in blue. So we've finished converging actually on our Ubuntu machine, and now we're waiting for the CentOS machine to finish. So we can talk briefly about Bookshelf. This works if you're familiar with other Ruby stuff. This works very similar to a gem file. It creates you put a series of required cookbooks in here, and then it creates a bookshelf.lock, which then for each one of these cookbooks, they required often additional cookbooks. It will figure out all those dependencies and then lock the versions for each. So we have any questions to the point? Am I losing you guys? So as we're reading here, for some reason on the CentOS machine, it's installing a bunch of development tools. So something that we required, and the cookbook believed that it needed a whole set of development tools to solve converging this machine. And we can look at our Perks file and get a list of all of the cookbooks that did get pulled in here. And you can see Build Essentials is in that list. This is actually often required in many cookbooks, and is just a full set of development tools. Yeah, it does look like he's got a pull request here where somebody did update that checksum, and he just hasn't merged it in yet. So, And we're finished. So we do kitchen list. Now we will see that we've got 2 machines that are converged. We could log in to either one of these. Kitchen or login default CentOS 6.5. We can see that Minecraft is running. Do a service Minecraft status. We can also now write kitchen verify, and it will run through it will upload our server spec tests that we wrote before, and then run on both of the machines, and we'll be able to make sure that our integration tests pass. Oh, and did not. Undefined. So this failed on. Let's see, I'm not sure here. Should be running. Oh, syntactical problem. Service. Okay, and so both of our tests have succeeded. If we do a kitchen list now, it'll tell us that both of our integration tests have passed. So we can now add some more integration tests here. One of the options that we had in this cookbook was that it was setting the amount of memory used by our Minecraft server that we're going to hand over to Java. And what it's doing here is it's actually getting the amount of memory that is in the machine and taking a percentage of that memory. And then, you know, setting so we could take this here, this formula, and say we'd like to only give 30% of the memory So change that guy. And because we've done this, we probably want to create an integration test for this. Now, we're not going to create a spec test for this because this doesn't actually change any code. This is basically setting a variable, and you don't create unit tests for variables. But we do want to make sure the outcome was that it actually changed the amount of memory. So I'm actually just going to rerun our test, so we can see that the amount actually does change, and then we'll put in a test to make sure that change is always there from now on. So we can see that it has it's changed a number of these options. So this is the values that we're actually going to be looking for, and it's changed our config file here. Again, it's done this for both machines, and I'm going to, for our service, describe command Java should match. Its args should match and I'm just basically handing in a regular expression here. The syntax for this here we can pick up off the server spec site. So if we take a look at command, it's able to check the, actually we don't want command, we want service. Do we want service? Sorry, daemon. Here, we'll do it like this. Yes. Grab Java. And we want to test the output of this matches this syntax here. So what's going to happen in this test is it's going to run a process list, it's going to grep for Java, and we're looking for it to match these arguments. So if we run verify again, oh. Standard out. All right, this failed for us, so let's actually log on to one of the machines. Oh. Okay, so we can see it passed on our CentOS machine, but on our so on our Ubuntu machine we have a failure. So let's log into it. Okay, so interesting. The 30% of the memory from the Ubuntu machine versus the CentOS machine, we get a slightly different number, even though both of them should have gotten basically the same amount of memory. Yeah, no, Vagrant has defined a slightly different amount of memory for each of the machines. We can actually specify how much memory to give each one of the machines in our kitchen file. But for me to do this, I'd actually have to destroy the machines and recreate them again, and we'd all have to sit through installing Java. So that basically wraps it up. We have a pretty good set of tests here. If like I said, if we had the same amount of memory in each one of the machines, that integration test would have worked. Does anybody have any questions or anything we want to cover? Okay, so if anybody needs to or got stuck during the lab at some point, if you want to hit me up later, we can go over whatever parts you got caught up on. Okay. So that basically finishes what we've got for the lab. Thanks. Did anybody like have any general questions about Chef that we wanted to cover, or things that you Yeah. Okay. Briefly, I think I talked about chef provisioning. Um, that this is a set of stuff that's coming out. It was until recently called Chef Metal. If you want to Google around for it, that may be the thing to actually look for. You'll find a lot more information about Chef Metal than provisioning right at the moment. But it talks about how you would actually define using chef code a whole set of architecture, which then you could move from one cloud to the next or your private cloud. What we've done basically here tonight was for just doing the testing of Chef itself. Now, at this point, what you would normally do is you've tested out your cookbook, everything's good, you commit everything up to your repo, and then you would upload your cookbook to your actual chef server. And to do that, we would use the that Burks command again. You would type Burks upload, and based on some configuration parameters that you would supply it, or you would put in a chef configuration file, it would know where your chef server was, and then it would update your cookbook. So each time you go to make a change to your cookbooks from this point, you would be able to run through all of the unit and integration testing, and you'd have a pretty solid idea that it was going to do what you expected it to do before you send it out to your production machines. Then you could after your integration test passed, you could upload that directly to your chef server. You could also, what we've covered here, bring in Jenkins and do like a full-blown continuous integration where you would have your Jenkins server running through those RSpec tests and then using Kitchen to create virtuals and run through your chef tests and your server spec tests to make sure that your config was good. Kitchen, by default, out of the box, is set up to work with Vagrant, but it also supports a number of other things, including AWS directly. So you can have it. You could write a Kitchen file that will create your virtual instances in AWS for you, and then run against those instances. If your endpoint is AWS, it's probably better to test against actual AWS instances as opposed to for example, if you're using Amazon's distro of Linux, you'd want to test against it instead of CentOS or Ubuntu. So we've covered a whole bunch of stuff. If anybody doesn't have any more questions, I'll go ahead and wrap this up now. Yeah, no problem, Ramir. All right, guys. Well, we'll see you later.